Hello everyone, I am Dr. Shrestha and you are watching Erudite Chemistry. In last video, we were talking about Mendeleev's periodic table and we came to know that Mendeleev was arranging his table, the elements in his table using two concepts. The first one, he was arranging them in order of increasing atomic masses, and second thing that he was taking care of chemical properties of the element also. And just because he observed that there is periodicity in the properties, after a certain interval elements show similar kind of properties, he has given one law called Mendeleev's periodic law. And this law states that physical and chemical properties of elements are periodic function of their atomic masses. This is Mendeleev's periodic law. But as we know that there were again many flaws were there in Mendeleev's periodic table also. So scientists were still working on arrangement pattern. That is, they wanted to arrange elements in a better way. And ultimately we got an idea, and this idea was given by Henry Moseley in 1913. Actually, Henry Moseley was doing an experiment in which he was trying to find out the relationship between the frequency of the X-rays with the atomic mass of element from which these X-rays are coming out. In his experiment, what he was doing is he was bombarding the electron on various metals, and X-rays were coming out from these metals. And he was trying to find out the relationship between the frequency of the X-rays coming out with the element atomic number and atomic masses also. And when he plotted the graph between square root of frequency of X-rays coming out from the metal and atomic number of the metal, he came to know that this graph between this and this graph was a straight line graph, which means that this V is directly proportional to this frequency is directly proportional to the atomic number of the element. But when he draw the graph between nu, square root of nu versus atomic mass, he found that this graph was not a straight line. So actually it was not depending on atomic mass, but it was directly proportional to the atomic number of the element. So what he suggested is, he suggested that why we are bothering about the atomic masses, why we are talking about the atomic masses when we want to explain the chemical property of any element. Actually we should concentrate on the atomic number rather atomic masses. And this idea was actually logical, because now we know this thing that the chemical properties of any element depend on the electronic configuration of the element, and electronic configuration is because of the electrons, and there is nothing to do with the atomic mass which lie in the nucleus at the center of the atom, isn't it? So by understanding this concept, everyone agreed with this concept that we should go ahead using atomic number and leave the atomic mass concept. Hence, modifications were made in the Mendeleev's periodic law, and it was converted into modern periodic law, which states that physical and chemical properties of the elements are periodic function of their atomic numbers. So what was the major change here? That the physical and chemical properties of the element are periodic function of their atomic number. And then everything was sorted out. That is, we wanted to make the arrangement as per atomic number now. And when we started doing that, we came to know that the elements are automatically getting arranged in a proper way, and there was no gap in between. And just because the electronic configuration was the basis, Bohr's electronic configuration was the basis of this periodic table, which is now new modern periodic table, this is now known as Bohr's periodic table also, or long form of periodic table. Three other scientists, Rank, Werner and Bury, they also worked very hard along with Bohr to make this table. So Here we have our modern periodic table. Now let us understand this table in detail and try to recognize each and every concept behind this table. So let's start with the group and period which are present in this table. So let's see to it. Here you can see the vertical columns. You can see there, and there were horizontal lines in this periodic table. These vertical columns are called groups. As you can see, starting from there, you can clearly see that there is 1, 2. Starting from 1 and 2, we are having 18 vertical columns, and these are the 18 groups. And whenever you are moving this way, that is, if I am talking about nickel, palladium, platinum, that means I am talking about element in a particular group. So these are the groups. Vertical columns are the groups. On the other hand side, there are 7 periods in this periodic table. So you can see there, starting from 1 to 7, continuously there are 7 periods. And 7 periods mean we are having these. So you can see there, horizontal rows are there, and these horizontal rows are known as periods. This table is also classified in 4 blocks. These blocks are S block, P block, D block and F block. S block elements are the elements which are present in the first and second group. So first and second group elements are called S block elements. Now from 13 to 18 group, that is 13 group to 18 group, these elements are called P block element, and the elements from 3 group to 12 group, that is 3rd group to 12th group, these elements are called D block element. And some of the elements are kept at the downside of the periodic table in a separate 2 different rows. These are called F block elements. So these are separate rows, and these are F block elements. So the entire table is divided into 4 blocks. So 4 major blocks are containing S, P, D and F. S block first and second, P block 13 to 18 and D block 3rd to 12, and F block are the separate 2 rows which are kept at the downside. So this is how the blocks are divided. Now we will justify the presence of various elements in a particular group, and then we will justify the presence of elements in various periods. So I am taking first of all the groups, and I am going to justify why these elements are present in that particular group. So let's take the example of second group. I am taking the example of second group having beryllium and magnesium and calcium. We know that atomic number of beryllium is 4, this is 12 and this is 20. And the electronic configuration of beryllium is 2, 2, magnesium is 2, 8, 2 and calcium is 2, 8, 8, 2. So all of you can see here very clearly that all these 3 elements are having 2, 2 and 2 electrons in their outermost shell. So obviously these elements will show +2 valency, because if they want to exist, they have to lose 2 electrons to justify octet rule. Is it clear? So they show +2 kind of ion, just like magnesium make Mg+2, calcium make Ca+2, and that is why they show the similar kind of properties. And just because they are showing the similar kind of properties, having same kind of configuration, they are kept in the same group. So same group indicates similar kind of outermost shell electronic configuration. So if you find any element in a particular group, you just understand that this will definitely show the similarity with the other element present in that particular group. I hope it is clear to you, or I have to take one more example. So let's take one more example. So here I am taking one more example, that is I am taking oxygen and sulfur. Okay, so let's see what is oxygen. Oxygen is 8 and the configuration is 2, 6. Sulfur is 16 and the configuration is 2, 8 and 6. Now oxygen and sulfur both are having 6 electrons in the outermost shell. Just because they are having 6 electrons in the outermost shell, these are kept in the same group. Actually I am not taking the elements more than 20 atomic number, just because they are not in your syllabus, and I am dealing with only up to 20 atomic number element. Okay, otherwise this particular concept applies for all elements present here. So it is not only the atomic number up to 20, it is applied to the all elements present in that particular group. Now we will see that what does a period of periodic table indicate. So let's take the example of period in the periodic table. So here we have elements of second period. These all elements belong to second period, and here now I am going to tell you why they are kept in the second period, or what does this period indicates. What do you understand by if any element is in a particular period? So let's see to it. Atomic number of lithium is 3. So I am writing down the configuration of lithium. The configuration of lithium is 2, 1. It is 2, 2. It is 2, 3. It is 2, 4. 2, 5. 2, 6. 2, 7. And 2, 8. All of you can see here that this lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon, these all elements are having only 2 shells. Only 2 shells. And just because they are having only 2 shells, they are given second period in the periodic table. So what does period indicate? Period indicates the number of shell, or I can say the number of period of an element in the periodic table is the number of shell present in that element. So I hope it is very clear to you that the period indicates number of shell. You can apply the same concept to the any other group, any other period also. That is, I can take it for the calcium, potassium. So let's do it for the potassium and calcium. If they are present, look at the position. That is, it is present in the fourth period. So if they are kept in the fourth period, so obviously they must be having 4 shells in them. So let's find it out. What is potassium? It is 19. What is calcium? It is 20. Atomic number 19 means 2, 8, 8 and 1. And this is 2, 8, 8 and 2. 1, 2, 3, 4. 1, 2, 3, 4. Both of them are having 4 electrons. Both of them are having 4 shells in them, and that is why they are kept in the fourth period in the periodic table. I hope it is very clear to you. Okay, now let's talk about the special names given to the different groups in the periodic table. Let's start with the first group. The first group element here, this first group element are known as alkylide metal. The reason is that all these metals which are present in the first group, they react with the water to form hydroxide, and these hydroxide are soluble in water, and just because they are soluble in water, they are called alkali. So these metals which are present in the first group, these are called alkylide metal. So do remember, first group elements are also known as alkylide metals. Okay, second group elements are also alkali metals, but just because they are found in the earth crust, their another name is alkaline earth metal. So second group elements are known as alkaline earth metal. Okay, so first group elements are called alkali metals, second group elements are called alkaline earth metal, just because they are also from alkali. Next is 13 and 14. 13 and 14 elements, group elements are not given a particular name, but 15th group elements are called nicogens. 16th group element, because they form ores, they are also called chalcogens. 17th group elements are very famous, and they are very famous by the name halogens. And 18th group elements, they are very well known by the name inert gases. They are called inert gases just because their octet is completed and they do not react at all. So these are called inert gases or noble gases. So these are the special names given to these elements. Now let us see the atomic number of these elements and see how they are arranged in the periodic table and how we are getting them in sequence. So I am starting from the hydrogen. From the hydrogen, here, hydrogen is still a drawback in the periodic table. There is no particular position for the hydrogen. Apart from that, we have another flaw in this periodic table, and that is the element, F block element. These are kept outside the table, which are not given a proper place inside the main frame of periodic table. So this hydrogen and these F block elements, these are the flaws of periodic table. But right now I am talking about the atomic number and the arrangement of elements in the periodic table in sequence. So let's see how they are arranged. Hydrogen, as I told you, it is not given a proper place, so I am not discussing it. But after the hydrogen, we have helium. Hydrogen and helium both are having only one shell, that is why they are in this first period. After that, when we talk about lithium, lithium is having two shells, that is why it is kept in the second period. And after the lithium, we will see that beryllium and then boron, carbon, nitrogen, oxygen, fluorine and neon. Just after the completion of neon, this second period, just after the completion of second period, you have to move to the third period. So the third period will begin here with the sodium, and from the sodium and magnesium we have to move with the aluminium, silicon, phosphorus, sulphur, chlorine and argon. Once this third period is completed, then you have to go for the fourth period. And you can see there that continuously we are having the atomic number. There is no gap in between any element. So there is no scope for any element to be there in between these elements. So there is no scope for the flaw in the periodic table actually. Up to lanthanum, there is no gap. We are continuously writing down the atomic number, and up to lanthanum there is no gap, but after the lanthanum you can see there is gap of 57 to 72. Some elements after the lanthanum are not there in this table. Where they are? They are actually 14 elements after the lanthanum. 14 elements. After the gap of 14 elements, we have kept hafnium here. The atomic number of hafnium is 72 and atomic number of lanthanum is 57. And between these, there are 14 elements, and where they are? They are kept at the downside in the periodic table. And just because these elements are following lanthanum, these are called lanthanoids. What are the other name of these elements? Lanthanoids. And if you are asked that to which period they belong to 6th period, because I am taking lanthanum from the 6th period. So actually these first series of the F block belong to 6th period. And after that we will be continuously writing down the atomic number up to 86 till that 6th period is not completed. After the completion of 6th period, we have to start with the francium, which is the 7th period. Up to actinium, there is no problem, that is 89 tak. We have to write down the number in continuous manner. But after 89, again you can see that there is a gap of 14 elements. After actinium, 89 के बाद 90th element from thorium to the 103 atomic number lawrencium. These 14 elements are again kept at the downside in the second series of the F block element, and these elements which are following the actinium, these are known as actinoids. So what they are known as? Actinoids. And if I talk to you about the period of these elements, can you see there? I have picked them after the actinium. So these belong to 7th period. So the first series, that is lanthanoid, belong to 6th period, and the second series actinoid belong to the 7th period. So I hope it is now clear to you that you have to continuously write down the atomic number from the left to right till the period is completed, and then you have to continue from the next period. But take care that you have to stop here at the lanthanum, then you have to continue with the 14th element, and then you have to stop up to actinium. So this is all about the periodic table, and we know that this periodic table is very important for us because we are learning a lot about the property of the element by understanding this table. So I hope this video will be helpful for you to understand this table. So if you like this video, please hit the like button and share it and subscribe it. Thank you very much.